Good evening to all of you. My name is Asif Sheikh. I'm a Physics IIT Foundation teacher. For the past 15 years I have been teaching. Over a period of 10 years I have been teaching physics. Exclusively I am teaching Physics IIT Foundation classes for the past 7 years, more than 7 years we can say. So the reputed schools I have worked in the schools like Pashyam, Sri Chaitanya, Mandangi Concept School, Kennedy, Next Gen, Sarojini Vidyalaya, Miller, and recent schools are like SR Prime School in Telangana, which is a CBSE, and currently I am working in Tejasvi High School as a IIT Foundation teacher. Okay, so as a part of demo, let's have a discussion. In current electricity chapter, there is a small concept, that is KVL, and in addition to that, Wheatstone bridge, and one more I will explain with an example to Wheatstone bridge, the problem which was given in the most recent exam JEE Mains 2025. Okay, so let's discuss the current electricity chapter. In that, the small concept KVL we will be going to discuss. Okay, so current electricity chapter, and this KVL, Wheatstone bridge, next one example for this Wheatstone bridge. I will give one example, one problem. Actually the problem was given in the most recent exam JEE Mains 2025. Okay, January first session. Okay, so KVL. What is KVL? Kirchhoff's voltage law. It is also known as Kirchhoff's loop law. Okay, what is it? The algebraic sum of differences in potential difference. What is that? The algebraic sum of the differences of potential difference is equal to 0. See, actually potential difference is V. The difference in potential differences means delta V across the circuit, which can be taken as algebraic sum, including the EMFs as we are traversing in the loop, must be 0. Okay, so this is the KVL. Understood? So by taking one circuit diagram, let's discuss this KVL. So in our circuit diagram we are having three resistors, namely R1, R2, E1, E2. Okay, so we'll derive two equations. Okay, we'll derive two equations by applying KVL. Okay, so first thing is define the circuit. Means just name the nodes A, B, C, D, E, F at the terminals. Okay, first naming or defining the circuit. Next we are traversing. So take the direction how we are traversing. Let's say I1 is a current that has been drawn from E1, I2 be the current from E2, putting together from KCL, Kirchhoff's current law, which is it is also known as Kirchhoff's junction law also, or node law. So KCL, the sum of the currents moving towards is equal to the sum of the currents moving away from the node. So as two currents are approaching towards the F, which is equal to the current which is moving away from this F node, which is equal to I1 plus I2, that is passing through the resistor R, which is kept in between A and B. Okay, so now we are going to derive the two equations. So first one is defining the circuit, second one is traversing direction. So let's take, as we are traveling or traversing, A, B, C, F, A. Okay, we are traversing in this way. See, if we are moving in the current direction, that will be negative. If we are passing over a EMF source, if we are traveling from plus to minus, then the direction will be minus. If we are traveling from negative to positive this way, then it will be taken as positive. Okay, keep this 2 points in the mind now. Okay, from A. So I1, I2 current is the total current passing through the resistor R. We are moving in the same direction. If we are moving in the current direction, then it will be taken as negative. If we are passing opposite to the current direction, then it will be taken as positive. Okay, so as we are moving in the current direction, that will be taken as negative. Now we are coming here again, C to F, right? So the current through this R2 is I2 R2. We are moving in the current direction, that's why I have taken negative. Now the EMF source E2, which is equal to from negative to positive, where here negative to positive means positive, so plus E2, which is equal to 0. The same law KVL is applied to the second loop. So what is the second loop? I am starting from the F, C, D, E, F. Okay, right? So here I am starting from this. So what is the device that we made first? That is E2. Okay, from positive to negative means positive to negative. So E2 thus negative. As I am passing through R2 resistor, so I2 R2 is a difference in potential difference, should be negative or positive. We are moving opposite to the current. Opposite to the current means positive. Okay. Next, here, as we are traversing R1 to the R1, then in the direction of current. So minus I1.